Hello there, everybody, and welcome to the day 4 of the Basic ROS Learning Week. Welcome, everybody, to one day more of this week of live classes we are doing in order to learn some basic ROS. First of all, before starting, a couple of things. First of all, let me know if image, sound, and everything is correct. Let me know in the chat so that I can continue without any concern. And then I want to address a couple of things before starting. So first of all, let me switch one moment. Well, let me check here if I can see in the comments if everything is right so that I can continue talking. Let me know, please. Here. Hello, Alberto. I can see here many of the names as well from previous live classes. Also some new names, which it's good. Hello Alberto, day 4, Mauricio Ferrari, hello Mauricio, hello Alex, Marco Antonio Becerra is saying all correct. Okay, so yeah, you do great. Thank you very much, team, thank you very much. Okay, so let's go. First of all, I want to explain here very quickly our schedule. So we are on Thursday, yep. So we started on Monday with Linux for Robotics, then on Tuesday we went for Python for Robotics, then some of you have done the evaluation test, I have seen, which is great. Then yesterday we had the ROS Basic Concepts live class, where we started learning about ROS, some main concepts for ROS like ROS nodes, ROS packages, launch files, compilation, etc. So that you have a base knowledge of what is ROS. And I have seen as well, we had some problems yesterday, in the live class of yesterday we had some problems, but I have seen in the Discord channel that some of you have been completing this project, the one from yesterday, during today and also yesterday after the live class, which is great. So yeah, I want to talk now also about, well, today, of course, we are on Thursday and we are going to do ROS topics and messages, which basically it's the big day from the week. Yeah, so this is the big day where we are going to do all the core things that are going to allow us to complete successfully the ROS Robotics Challenge from tomorrow. Yeah, so today, ROS topics and messages. Then, before going to the thing, well, actually, let's do one thing. First of all, I'm going to share with you the ROSject link. Let me change to my view. Hello back. So first of all, I'm going to share with you the ROSject as I did yesterday. Yeah, I'm going to put the link in the channel. In fact, I'm going to do it right now. Let me come here, grab it and paste it. So all of you, please get this link. Let me paste it here. There it goes. Okay, so I have just placed the link here in the chat so that all of you are going to be able to see it. Then all of you, I want you to go to the ROS Development Studio here and paste the link here. Yes, in your ROS Development Studio workspace. And then once you paste the URL here, you are going to get this ROSject, Basic ROS Learning Week Day 4. Yes? Then, in fact, let me start opening this. All right, then as soon as you get this ROSject, I'm going to open this again. Okay, so as soon as you get this ROSject in your workspace, you have to click on the open button, as I have just done. I'm going to repeat it here. So this is the ROSject from yesterday, Basic ROS Learning Week Day 3, and for today it's going to be Basic ROS Learning Week Day 4. Yeah, then you have to click here on the open button and open ROSject. Yep. So all of you have the link. I have placed it in the channel. So let me have a look here at how the comments are going. Let me know if everything is going great. Meanwhile, my ROSject is loading, which I have it here loading. Yep, this might take a couple of minutes, so just be a little bit patient. Let me see if everybody has received it. Okay, loaded, Richard Voice. Okay, so it seems like it's going well. Loading. No problems at the moment, so everything seems to be working fine, which is great. Let me see. I already have the project. Okay, great. Loading, engineering nation. Okay, excellent. So let me load it. Okay, great. So apparently we have no issues today. So as I've said before, yesterday we had some issues. I want to talk to you about that right now because we don't want to hide anything. So yesterday we had basically a couple of issues. One, it was an overloading issue. So we had a peak in the connections to the ROS to the ROS Development Studio server, which caused some issues there, where the page was not loading properly, etc. Yeah, but ultimately this issue was solved, so everybody was able to access the ROS Development Studio. But then there was another different issue, which was by loading the project. So some of you were trying to load the project from your ROS environment, and the project was not loading. So you had the loading screen, but it never finished loading. Yeah, and this issue is because of an unexpected issue. Let's say there was an update, and well, basically there was an issue that made some of our servers fall. Yeah, so basically we have 4 servers. We have one for Europe, another one for America, another one for Asia, and another one for Australia. Yes, then all servers except the one in Europe were down. Yeah, so went off, were fallen. Yeah, so basically everybody who was trying to load a project outside the Europe zone was not being able to do so. Then during live class, my colleagues and also after the live class, we were working on this and we solved it. Yeah, so that's why after the live class, some of you could already start doing the project, and also today. Yeah, so basically all of this should be fixed for today. So today everybody should be able to follow with me the live class, and we should be able to complete it without errors. Yeah, so let me go back one more time to the channel to see how things are loading. Okay. Excellent, so nice to see the chat like this, loading, loaded, loading, done, loaded and ready to go. Okay, excellent, so it's amazing to see that everybody is able to load properly the project, the web page, and to follow alongside with me. Okay, so once we have this setup, everybody has the project, let's start, so let's go for it. Yeah? So I'm going to come here to my computer and I'm going to start. Yeah? So as yesterday, we are in the same environment, ROS Development Studio, and we have the notebook here for the basic ROS Learning Week Day 4. Yeah? As I've said before, let me make this bigger. Today we are going to discuss about ROS topics and messages. Yeah? Then what we are going to learn specifically today. Basically, we are going to learn what are ROS topics and how to manage them. What is a topic publisher and how to create one? What are topic messages and how they work? What is a topic subscriber and how to create one? And finally, how to create your own custom message. Yes? Then for being able to properly follow this class, you should have basics of some basic knowledge of Linux, basic knowledge of Python, and basic knowledge of ROS, which basically is what we have been doing alongside this week on Monday, Tuesday, and yesterday. Yeah, so you already have these requirements, and then we are going to start by setting up the environment. Yeah, well, before let me talk about our project for the ones who don't know. So for the new ones, this is a project. What you have in your computer is a project, which basically it's a ROS project. Yeah, it contains a notebook, a Jupyter notebook here, where you can write whatever you want, and then you have also some packages, ROS packages, simulation packages for Gazebo. You have shell, so it's an environment where you can work with ROS, create your own packages, develop your own projects. Yes. Another thing that is coming to my mind. So yesterday, some of you had issues here with the IDE. Like, it seems like I'm having it right now. So if your IDE is not loading and it keeps showing this screen, yeah, just come here and click here on the refresh button. Yeah. So if you have the same issue where the IDE is not loading, come here, click here on the refresh button or reload button. I'm going to do it right now. and this is going to restart, reload, and it's going to show properly, yeah? So here, as I was saying, we have all the packages, workspaces where you can place your packages, create ROS packages, modify them, etc, etc, yeah? And the interesting thing about this is that when you finish with your ROS project, you can basically save everything, and with a simple URL link, you can share your project with anybody, anywhere around the world, yeah? Which is basically what I have done just now, yeah? So I have my ROS project here, I save it, and I've shared it with all of you, so that you have exactly the same project I have here from wherever you are, yes? All right, so this is a ROS project. If you want to learn more about projects, how to create projects, etc., you can check these links. And now let's go with the setting up the environment, which basically it's the same as yesterday, yeah? So we are going to be working on the same simulation. So for this, we are going to come here to the simulations menu here at the top bar. Here we have it, simulations, choose launch file. I'm going to click here on the choose launch file button. And here from the launches lists, I'm going to go and find the Turtlebot Gazebo package here in black letters. You have it, Turtlebot Gazebo package, and from this package I'm going to choose the main.launch file, yeah? Under Turtlebot Gazebo, the main.launch. I'm going to select this one and click on the launch button. Then this is going to automatically start a gazebo simulation, yes? We have it here. So this has automatically opened a gazebo window, which is going to load a gazebo simulation, yeah? Which in this case, it's going to show here the Turtlebot 2 robot with a wall in front of it, yeah? Here my simulation is loading. It might take some seconds. Let me have a drink here of my, let me show, okay? So I'm going to have a drink here of my ROS Developers cup of coffee. Cheers. All right, let's go back to work. Okay, so here I have my simulation, my gazebo simulation loaded. And all of you should be at this point, yeah? So now, after the setup, I'm going to start explaining things and doing things. So, but before, I want you to all be on the same point as I am, yeah? So you should have your project loaded with your notebook here, where you are going to be able to check all the theory I'm going to be explaining, and also code the examples, etc. So you should have here your Jupyter notebook opened, and your gazebo simulation here loaded with Turtlebot and the wall in front of it, yep. And also the IDE here opened, because we are going to be checking files, etc. Yep, so, okay, before going on, let me have a look at the chat, and let's see how you are doing. Okay. I can see here one comment. It says, either not loading again, just as yesterday. Yeah, if your IDE is not loading, just do as I have explained it and click here on the refresh button. Yep. And this is going to reload your IDE, and it's going to load properly. Yes. So in case your IDE is not working, remember, click here on the reload button. So let me keep saying here. Thank you, it loaded after some refreshes. All right. I can see here Carlos Araya Jimenez is saying, hello, can you guys share the Discord invitation link again? Yesterday is dead. So the yesterday's link is dead. Okay, so I only have yesterday's link, so I'm going to ask now my colleagues if please you can share again in the chat here the Discord link so that everybody can join our Discord community. Which, by the way, I have been seeing that since yesterday, where we created it and shared the link, it's many people has joined our Discord server, which is excellent, and many people is talking between them and sharing their thoughts, so it's great. So please, yeah, my colleagues who are here in the chat, let's try to share again the Discord link, please. Okay, I'm seeing also some comments to share the link of the project for the late ones. Okay, I'm going to do it one more time. Let me share one more time the ROSjet link. I have it here. Here you have the ROSjet link one more time. Okay, so I have just shared the ROSjet link. So all of you click here on the ROSjet link and start opening your project. Yep. Okay, so yeah, apparently everything is, I can see some problems in the IDE, which I have already explained and my colleagues here are handling. So I have just posted here the ROSjet for the ones who have arrived late. And great, so I am going to, I can see that my colleagues are generating the new Discord link. All right, so let's keep going. Yeah, let's don't lose any more time with this and let's start working. All right, so today we are going to work with basically topics and messages. Yeah, and the first part, we are going to talk about topic publishers. Yes, so before actually explaining what a topic publisher is and what a topic is and how it works, we are going to do a very quick example. Yes, so we are going to execute this piece of Python code. So for this, all we need to do is to come here, select this cell. You are going to see when you select the cell code here, it's going to have the borders in green. You are going to see. So now I'm going to select another one. Yeah. And when I click here, well, it's in blue also. So when you click on the code cell in the Jupyter notebook, it's going to have here the borders in blue. Yeah. So now what you can do is to run this code. Yeah. So click here on the play button and on the run button, and this is going to, well, actually we could do it like this, but I think it's going to be more interesting if we just launch it, because that way we are going to be able to create a new package, or well, we are going to do that later. It doesn't matter. So you can come here and press on the run button. Yeah, and this is going to start running this piece of code, the one with the cell selected. So I'm going to click here on run, and you're going to see that here a symbol appears which tells that my code is now running. Yes, actually I think I'm going to do it with packages, because maybe this is going to be a little bit confusing for you. So I'm going to do it with a new package. So okay, forget what I have said until now. I'm going to do it with packages. So let's come here, and I'm going to come first of all to the Catkin workspace SRC. Yeah, so I'm going to start applying what we learned yesterday. So remember, every time you want to create a new package, you need to be on the Catkin workspace source directory. Yes, then the command, it was catkin create package. You can put the name you want for your package. In my case, I'm going to name it, I don't know, topic publisher. Yes, and I'm going to put as a dependency ROSPy. Yes, so catkin underscore create underscore package and topic publisher as the name in my case, and as a dependency I'm going to select ROSPy. Yes, then this is going to create my package. I'm going to be able to visualize it here in my Catkin workspace SRC folder. Yeah, so here inside I have my package topic publisher with the same list file, package XML, which we explained yesterday. Yeah, so we have everything. Then now inside the SRC folder, I'm going to create a new Python script. Yeah, so I'm going to click here, new file, and I'm going to name it as I have here, simple topic publisher.py. Yes, so I'm going to give this name, simple topic publisher.py, and I am going to paste this code into this file. So let me come here, select all the code, copy it and paste it into my Python script. There we go. Yep. Then one thing I should do now is to make sure that this script is executable. So I'm going to come inside the topic publisher package, which I have just created, inside the src folder, and I'm going to assign execution permissions to this script. So chmod +x simple topic publisher.py. Yep. So now it shows green, and now I have it with execution permissions. Alright, so I have my package, I have my script. So what is missing? Well, what is missing is the launch file. Yeah, so I'm going to create a launch file in order to start my program. So I'm going to come here to the topic publisher package. I'm going to create a new folder, which I'm going to name it launch. Yeah? Why launch? Well, because it's going to contain launch files. Yes? Then inside my launch folder, I'm going to create a new file, which is going to be, I'm going to name it simple topic publisher.launch in this case. Yes? Very important extension, .launch, because it is a launch file. Alright. So here I have it. And then I am going to fulfill my launch file. So I'm going to start with an opening launch tag and a closing launch tag. Then a node tag here. So I'm also going to close here. And then I have to specify, you remember this from yesterday? Yes? Yesterday we explained exactly this, how to create a launch file. Let me make this bigger so that you can see it bigger. Okay, launch node package. The name of my package is topic publisher. Yes, then the name of my script is simple topic publisher.py. Then the name of my node, of my ROS node, is topic publisher. So I'm going to name it like this. Topic publisher. And finally, the output, I'm going to set it to screen. Yes, do you remember this from yesterday? So yesterday we explained exactly this, how to create a launch file. Yeah? All right, so I'm done. So I have created my package, I have created here my Python script, and I have created my launch file to start my program. Yes, my ROS program. All right, so now I am ready to launch it. So I'm going to launch it using the ROS launch command. Yeah, we also explained and talked about this command yesterday. Yeah, so basically here I have done a very quick summary of yesterday's live class in 5 minutes. So yeah, I'm going to launch my ROS program now. So ROS launch, topic publisher is the name of my package, and simple topic publisher.launch. Execute. Yes? And here I have my program running and pause it. And apparently nothing is happening. So apparently nothing is happening here. This has started, but I can see nothing here. Yes? So I'm going to leave it like this, and in a moment I'm going to have a look at the chat to see how you are doing. And we are going to come here and see what's going on. Yes? So why apparently nothing is happening, nothing in the simulation has changed. I can see any message here. So let's see. Okay, I can see a message from Gloria. Please have Alberto rearrange his panels so we can see them clearly. The panels are covering each other and it's hard to follow. Okay, Gloria, I'm going to do right now. All right, so I'm going to leave this left side to the Jupyter notebook. Then up here, I'm going to place the simulation. Then down here, I'm going to place the IDE, and here I'm going to put my shell. Yeah. Okay. So now, for now, the simulation, it's not important, so I can cover it. Yeah. So now we have here the the shell and the IDE. Yes, and I have as well here the notebook in case I want to come to it. All right, let me check more. Yeah, I will keep this in mind. Yeah, for the future. Yeah, I can see the message here from my colleagues. Alberto, please combine your screen so you show IDE and terminals at the same time. Okay, yeah. So this is just what I have done now. So I'm going to pay attention to this especially. You're going, okay, I can see some people here that is saying that I'm going too fast. Okay. Show the command line little higher so we can repeat the process. Okay, let me come here. Okay guys, so here you have everything I have done until the moment. Let me make this a bit bigger as well. Okay, yeah, no needed. Yeah, so basically I have come here to the Catkin workspace src. Yes, then I have executed this command here, catkin create package topic publisher. Yes, this is the catkin create package, the command used in order to create a new ROS package. Then here I have placed the name of my new package, which is topic underscore publisher, and here we have the dependencies, ROS Pi. Yes? This dependency, remember, also we talked about it yesterday, it's for being able to program ROS using Python. Yeah, that's why we are using this command here. Yep, I'm going to, by the way, let me do one quick thing here. So I'm going to copy this to the YouTube channel so that you can grab it. There it is. Yeah, so I have placed it in the chat, the first command, which is to create the package. Yeah, catkin create package, topic publisher, ROS Pi. Then, after this, I have basically created a new file here inside the src folder, which I have named simple topic publisher.py. Yes? Then, inside this file, I have just copy-pasted the code I have here in the notebook. Yeah? So I came here, I created a new file with this name, simple topic publisher.py. Then I copied all this code and I paste it into the file. Yeah? So I have here the same code I have here. Yes? Then one thing I have done is to make sure that this file I have created is executable. Yeah? So for this, I came inside the src folder where I have my script, and I have executed this command here. Let me also write it into the YouTube chat. Okay, so there you have as well the command I have used. Yes, this command, remember we talked about it on Monday, I think, on the Linux live class. So this command is basically to make sure that my script has execution permissions. You will see that your script will turn to green here, yes? And then after this, all I have done is to create a new folder inside my package, which I have named launch, yeah? So I have created a new directory here, a new folder inside my package, with the name launch, and inside this launch folder, I have created my launch file, which I have named exactly the same as the Python script, but with a different extension. Instead of .py, .launch. Yes, because it's a launch file. But the name is simple topic publisher .launch. Yes? Then inside, I don't know if I can copy this to you as well. So inside, I have generated the launch file. Yes? Exactly the same way we explained yesterday. So with the launch tags here, and inside one node tag with 4 parameters. The package parameter with the name of my package, which is topic publisher. Then the type parameter with the name of my Python script, which is simple topic publisher.py. Then the name parameter with the name of my ROS node, which is specified here in my program. Yeah, here in the init node line, I am giving a name to my ROS node. So I am putting the same name in my launch file, this topic publisher. Yes, and finally the output to screen, because I want to see the output of my program through the web shell. Yes, I'm going to try to pass you this as well on the chat. I don't know how it's going to show, but well, let me do it. I can close this, by the way. There you go. So I have placed the code for the launch file so that you can grab it. Diego Camilo, can you show us the full content of launch file? Yeah, I have just shown, and here right below, right now I have pasted the code here to the chat so that you can get it as well. I can see Ruben here is also helping you. I can see also Alex Charters here, which is giving some advices. All right, so let me know. Give me some feedback. Let me know if now you understand better what I have done, if you have been able to follow with this, with what I have explained now, more slowly and more detailed, and showing everything and pasting all the commands here to the YouTube chat. Shell window, please. Okay, there it goes, the shell window. Let's see. Okay, some people is getting an error here in the XML. Okay, make sure that you have it like this. Yeah, so let me make this bigger 1 second. So the XML has to be like this. You first have the launch tag, then you have a tabulation here, and inside this, yes, let me see. In fact, I'm going to do one thing. I'm going to copy paste it from the YouTube chat so that I can get the same error as you have, guys. So I will copy it from the YouTube chat. Give me 1 second. Okay. Done. Let me paste this. Okay, yeah. So when you copy paste it from the YouTube chat, you are going to have it like this. Yes. So basically, let's just remove all the white spaces here. In between, then in the node tag, press enter, and in the launch tag, press enter, so that you have all separated. You have the launch tag, the node tag below, and the launch tag below. Yes, and now come here at the beginning and click on the tabulation or 4 spaces, so that this gets not at the same level as the launch tag, but inside. Yes, a little bit of indentation. Yes, this is similar to when we discussed about indentation in Python. So you have to indentate this node tag there. Yep. Then now, if I execute this, it's going to work, or yeah, so like this, it's going to work. You can see here that I have just executed it, and it's going to work. So once you have this, you have to execute the ROS launch command to start your program, which I'm going to paste as well here to the YouTube chat, so that you can have it as well. There you have the ROS launch command. Okay. Let me come back here to show everything. Here you have the launch, the shell. Let me put it higher again so that you can see everything. And let me make this, let me put this like this, better. All right, so let me have a look at the chat. Nailed it. Okay, great, Raul. I can see Mauricio Ferrari saying, Alberto, it's missing the tag to close node. Yes and no. I'm going to... So, Mauricio is pointing in an interesting way that I don't have a node closing tag. Yes, this refers to this closing tag. Yes, and this is true, but a closing tag can be replaced with this. As you can see here, I have this inverted slash, yeah, which also means to close the tag. Yes, because I am starting and finishing the tag in the same line. I don't have anything inside except parameters, of course, but it's not like a launch tag that contains another tags inside. In this case, the node tag, it's opening and closing in the same line. So in this case, I can close it like this. Yes, with the inverted slash here, like this. Yes, otherwise I could also do like this. I could remove that slash and then close it here. Yes, this would also work. But this, doing this, is exactly the same as doing this. Yes, it's the same. It's just this is just a simplified way of doing it. Yep, but both things mean the same and work the same way. Yep. So let me go back to the... All right. Nuria Pujol is saying solve it. I missed a underscore from a file name in launch file. Okay, yeah, so make sure that the names are correct, yes? Of course. So the names, you have here the name of the Python file, which is simple topic publisher.py. I'm going to paste it as well, this. So this is the name of the Python script. And this is the name of the launch file. Yes? So it has the names have to be correct, have to be like this. All right, it's working. I can see here Tauhid Ahmed. Ben MC, very good question. Can you have different nodes in a single Python file? In a single Python file, no, you can't. Yes? So here, very good question, Ben, by the way. I like it very much because it's super interesting. So here, inside my Python file, you can see that I am initiating a node, a ROS node here, yes? Which I am naming topic publisher. Then, what Ben is asking is, could I start another node? For instance, here, instead of finishing the file, I want to start another node, which is called topic publisher 2. Then can you do this? No, you can't. This is not possible. Yes? So each Python file has to contain only one node. Yes? If you try to do this, you are going to get an error. Yes? So for each ROS program, for each ROS Python file, you can only have one ROS node. You can only initiate one ROS node. Yes? Very good question. Let me check here. Okay, yeah. Diego Camilo Peña is having another error, which I also already have explained. This error is Oh no, Diego. Okay, that looks, Diego. That looks like you have some name is incorrect in your launch file. All right. Yeah, I can see some people is answering already. Check if the launch file is created in the correct location and make sure you create the package under Kacking Workspace SRC. Yeah, let's show it one more time. So the package has to be created here inside Kacking Workspace SRC. Yes, inside this folder the package has to be created, and then inside the package you have to have the launch directory and the SRC directory. Then inside the SRC directory you have the Python script, and inside the launch directory you have the launch file. Yes? So this is the structure, and it worked. Okay. Good, it's working now. Thank you. Okay. Okay, so it seems like people finally is starting to get it working, and I have to continue, guys, because otherwise we are going to spend 2 hours on the first exercise and we are not going to advance anything. So I'm going to keep moving. Yeah, please review it by yourselves. You have here the structure. I have explained it here, the structure. You have all the commands. So, and my colleagues also are there trying to help you. So try to fix it. So let's keep going. Yep. So I'm going to continue going. So once I have my package structure, I'm going to execute it. Yes, and I'm going to do so with this command: ROS launch topic publisher and simple topic publisher dot launch. Yes, so I specify the ROS launch command with the name of my package and the name of my launch file. Then I hit on the enter button, and I am going to be executing my program. Yep. Then what happens? Well, apparently nothing. Yeah. So nothing changes in the simulation. Nothing apparently happens here. Yes. So what is going on? Why nothing is happening? Well, actually, it is happening something. Yes. So let's execute this command here. I'm coming here to a notebook. I'm copying the command here, and I'm going to paste it to another shell. So here, let me open another shell, and I'm going to execute this command here in the new shell. Yep, ROS topic list grep counter. Okay, so I can see here that a counter topic has been created. Yes, so this is one thing that is happening. Yeah, I can also execute, well, let's do it like this. Yes, so basically here I'm getting a list of all the topics and filtering for the counter name, and I can see here that there is a topic named counter that has been created. Yes, so this, we are going to come back to this later, so don't worry. Yes, so basically here we know that a counter topic is running. Yes, so now I'm going to do another thing. I'm going to execute this command, ROS topic info counter. Yeah, I come here to a notebook, copy it, and paste it here. So here I can get some information of this counter topic. I can see the type of message that it uses, which we are going to explain later about messages. I can see here publisher and subscriber. Okay, so this might sound to you familiar because we have, at the beginning of the class, we said that today we are going to talk about publishers and subscribers. And I can see that this topic, this counter topic, has a publisher named topic publisher, yes? And this name, it's kind of similar here to the ROS node that we were creating in our program, yes? So similar, this is suspicious. Yeah, but let's keep going. Let's do one last test. Let's execute this command here. ROS topic echo / counter. I'm going to come here to the notebook, copy it, and paste it here to my shell. ROS topic echo / counter. Let's see what I get here. Okay, So I can see a sequence of numbers here, starting from 300 in my case. In your case, it's going to be different. But I can see a sequence of number which keeps increasing by 1 unit, yeah? So 320, 321, 322, etc. And it keeps going, yes? You can see it here, until I stop. Of course, I'm going to hit now Ctrl+C, and I'm going to stop this command, yeah? So, what is going on here? So many things happening we have seen here, many things we have been checking. So what is going on here? Okay, let's have a look at our program. So what is this program actually doing? Let's go line by line. Yeah, first of all, we have the Python line here, which is setting the environment to Python so that my system knows that this is a Python script. Yep. We already saw this line yesterday as well, when we created our first ROS program. Let me have a quick drink. All right, so we already saw this line yesterday, and this, so sets, it tells the system that this is a Python script, yeah? Then, import ROSPy, so here we are importing the ROSPy module, which we also saw yesterday, and we are importing this module because we need to, we are going to be coding in Python, so we need this module in order to be able to do so, yes? So we import the ROSPy module. Next, what we are doing here? Here, we are importing a type of message. Yes? In this case, we are importing here the type of message integer. Yes? So this is an integer of 32 bits. Yes? So basically here, we are importing this type of message. Why? Because we are going to be using it later. Yes? In our program. So we need to import it first in order to use it later, yeah? Then here we are initiating a ROS node, yes? This line of code, also we saw it yesterday. Every time, remember, every time you write a ROS program, it has to start with this line, yes? Init node. You have to initiate a ROS node. We are naming it topic publisher, yes? Then here, new line. And this is the most important line here. Yes, so here we are creating a topic publisher. Yes? So basically we are doing one thing. Yes? Here we are telling that we want to create a new publisher. Yes? With the publisher keyword. Then we are specifying here the name of the topic we want to publish to. Yes? So this is going to create a new topic named counter. Yes? Then I am telling that inside this topic, I am going to publish messages of the type integer. Yes? So this topic is going to contain data, and this data is going to be of the type integer. Yeah? So into this topic, I'm not going to be able to publish strings, for instance, or floats. Yes? This topic, I am going only to be able to publish integer numbers because I have set this here when I have created this publisher, yes? So I create a new publisher which is going to publish into a topic named counter. It's going to publish messages of the type integer, and it's going to have a queue size of 1, yes? So this for now, just don't pay attention to it. You can set always a queue size of 1 by default, yes? So don't worry about this, yeah? Then, let's keep going. Okay, so here, I am creating a rate variable, yes? So this is going to help me later in the while loop to control the frequency of this loop, yes? So here I am creating a rate element of 2 Hz, yes? We also saw this yesterday, by the way, when we created the while loop. Yep. Then here we are creating a variable named count, which we are initializing to the integer type. Yes. So this variable is going to be an object of this integer. Yes. Then here we are accessing the data field of this message, which we are going to learn in a moment why we are doing this, but basically we are initializing this integer to 0, yes? So this is going to start from 0. Then I create here a while loop, which says while not ROS is shut down. You remember this from yesterday as well, we already used this. This basically says that while I don't stop my program manually, for instance with a Control-C, by pressing Control-C, so while I don't stop my program, this is going to keep happening, yes? This that we have inside the loop, it's going to keep happening until I stop my program with Control-C. Yes, this is what this means. Then, what am I doing here? I am publishing a count message, which right now is 0, into my topic. Into which topic? Into the counter topic. Yes? So here I am publishing this message, which now is 0, into the counter topic. I am publishing it. Yes? Then after this, I increase my integer in 1 unit. Yes? So now it's not going to be 0, but it's going to be 1. And then I set here an sleep to make sure that my loop maintains a rate of 2 Hz. And then I go back here. I will publish the number 1. Then I will come here, the number will increase, I will go back here, I will publish the number 3, then 4, then 5, then 6, then 7. And that's why when I check this topic, I can see a sequence of integers which keeps increasing. Yes? And this keeps increasing until when? Until I manually stop my program with Control-C, which I am going to do right now. I'm going to stop my program. I have done it here, and you can see now that the sequence of numbers has stopped increasing. Yes? So this is basically the meaning of this program, yeah? So now probably you have many questions, which I am going to try to answer right now. Let me have a good look here at the comment section. Mauricio Ferrari, there are more publishers and topics from the simulation. Do a ROS topic list to see all. Yep. So if we execute here the ROS topic list command, we are going to see all the publishers, all the topics that we have running. Yeah. Most of them are from the simulation, are related to the simulation. Yeah. Information of the robot. Let me have a quick look here. Okay, very good question. I love it. So here, Fabio Lisurici is asking, how can we know that in int32 there is the field called data? Okay, this is a very good question, but I am going to answer it a bit later. So in 10 minutes maximum, I'm going to answer it. Okay, Fabio, don't worry, because this is a very good question, and in fact, I'm going to explain it in a few moments. So don't worry. Thank you from Tunisia. You're welcome, Malek. Yes. Hello. Can we have multiple message types for a topic? Is asking Jibin T. Matthew. No, Jibin. So a topic, as you can see here, a topic has a message type associated to it. Yes, you cannot put here string or whatever. No, one topic has one message type associated to it. Yes, very good question as well. Jai Ganesh Shirin, what is the difference between topic and message? Okay, very well. So let me now do some clarifications. So, what is a topic? First of all, you might be asking, yeah, because we have reviewed the code here, we have seen some information. So, what is a topic? A topic basically is a channel, let's say. Yes? So, a topic is a channel of communication. It's a channel of communication. It's a channel that contains some type of data. Yes? For instance, in our case, the counter topic contained integer numbers, yes? But a topic can contain any type of information. For instance, it can contain information from the laser readings of the robot. Yes? In fact, there is a topic, which is this one, the Kabuki laser scan, which contains the information from the readings of the laser. Yes? So basically, in this robot, there is a program, there is a ROS program, a node, a ROS node, a program like this one, but much more complex, that basically is creating a publisher, and it's publishing information from the laser readings into a topic. Yes? And then, from another program, which is a ROS subscriber, which we are going to see later, you can read information from this topic and use it for whatever you want. Yes? So basically, a topic is a channel where you are going to put information. You are going to send information for anybody to use. Yes? This is a topic. It's a channel where you are going to put information. You are going to put data. And this data is the message. Yes? So a topic contains data, and this data is in the form of a message. Yes? So basically a topic contains messages. You are going to send messages through the topic. Yes? This is the difference between topic and message. So message is the actual data, is what contains the data, and topic is basically only the channel where you are going to send this data. Yep? So this is basically the difference between topics and messages. Then, a publisher, basically, what is a ROS publisher? Well, a ROS publisher is a program that publishes data, so that publishes messages into a topic, as simple as that. Yes, we can see here, in this case, we are publishing integers. Yes, so, but this is a ROS publisher. So a publisher is a ROS program that publishes messages into a topic. Yeah? Okay, then we have some messages that will allow us to interact with topics, to know more about topics. For instance, the first one here is ROS topic list. The ROS topic list command is going to show us all the topics that are currently running. Yeah, you can see here all the topics that are, you can see many topics related to the camera, for instance. Yeah, because this robot has a Kinect camera, you can see it here. Yes, you can see it there mounted. I don't know if it's a Kinect camera or an Ixtion, I'm not sure, but it has an RGBD camera. Yes. So ROS topic list command will show us all the topics that are currently available. Yep. Then we have the ROS topic echo command. This command, the ROS topic echo, is going to show us the information which is being published into a topic. Yes? For instance, before, when I executed ROS topic echo here, in my counter topic, I was able to visualize the messages that were being published into that topic. Yes? And I can do this with any topic. For instance, ROS topic echo, I'm going to do it with the laser one. But you are going to see now that the amount of data that I'm going to see, it's very big. Yes? So if I do ROS topic echo for the laser topic, I'm going to get a lot of information here. Yes? Let me stop it. But basically you need to know that the ROS topic echo allows you to see the messages, see the data that is being published into a topic. Yes? Then, for instance, you can do one thing. Let me start one more time my program so that I can show the examples with the counter topic. I'm going to start one more time my program. So I'm going to do here a ROS topic list now. So let me do one thing. First of all, let me stop everything and I'm going to do a ROS topic list. So now if I look for my counter topic, I'm not going to find it. Yes? So I can see here camera, clock, CMD vel, but I don't have any topic which is named counter. Why? Because my program is not running. So I'm going to start running my program now. There it goes, it's starting, and I'm going to execute again ROS topic list. And now I can see here my counter topic. So now it appears here, yes? So now I can do a ROS topic echo, I can connect to this topic and see what's going on here, what messages are being published. And I can see here the sequence of integers, yeah, that we explained here in the program. Yes? And also there is another command. So if I do a ROS topic echo counter and I add a minus n1 at the end, I'm going to get only the last message published. Let me execute it. So with this, I only get one message, the last one that has been published into a topic. I just see one message, yes? Not all of them, like this, yes? But only one. Then finally, we have the ROS topic info. So this command is going to give us information about a topic. Yes, what information? Well, first of all, the type. It gives us information about the type of message that this topic uses. In our case, we can see that our topic counter, we define it that it uses integer messages. Yes? And also, it says that this topic has one publisher, one ROS program that it's publishing into this topic. And what is this program that is publishing into this topic? It's our program. It's our program which is named Topic Publisher. You have it here in the init node. Yes? So this command tells us, hey, this topic uses integer messages. And it has one ROS program, which is this one, which is publishing actually into this topic. Yes? For instance, if I... Okay, yeah. So, a lot of information. Let me have a look at the before going for messages. Let me have a look at the chat, how things are going. Okay, let me check here. I like very much this comment. So I can see here Jake Nash Srinivasan. You have a hard name. So he says, so it means topic is the envelope and message is the content in the letter. Yeah, you could say that. Yes, you could say that. All right. Let me check more comments. Sandy's where? Okay, difference between mkdir and catkin create package. Okay, Sandy, let me explain this real quick. So the difference is huge. Mkdir is going to create a regular folder. So let me come here to the catkin workspace src, and I'm going to do mkdir directory. So this is just going to create a folder. Yes, this is a regular folder. A regular folder directory which doesn't contain anything. You can put things here, but it's empty. Yeah. So this is just a folder, a directory. Yes. You can see that it doesn't contain anything. Yes, it's empty. It's just a folder. Then let me remove it. Then catkin create package is going to create a catkin package. So let me name it directory. Catkin create package is going to create a ROS package, a full ROS package. So if I execute this, I can see here many feedback, and I can see that inside the folder, I have things here created, semi-glix package. So this is a ROS package. Yes? So mkdir is a Linux command. It just creates a folder, a Linux folder. Catkin create package is a ROS command. It creates a ROS package. That's the difference. All right, let me check more details, more comments, sorry. Let me have a drink. Let's see. ROS CD. Nabil Miri, can we create more than one publisher in a program file? Yes, you can, Nabil. You can create more than one publisher in a program. Let me check here. Super all good. Okay, Raúl Catacora Grundi. What's a node? What's a topic? And what's the difference? Okay. So, alright. So a topic, I have just explained it. A topic is a channel where you are going to send information, yes? It's a channel that contains information. This is a topic. As we have seen just now, a topic is a channel that contains information. Then a node is a ROS program, yes? So a node is this ROS program, yes? This ROS program is represented by a node, by a ROS node which is named topic publisher. We are initiating it here, yes? This ROS node named topic publisher contains this program, and inside this program I am publishing into a topic, yes? So I am publishing messages into a topic. But basically a ROS node is a ROS program, and the topic is just a channel where you are going to send information, send messages. That's the difference. So a node is a package? No, a node is not a package. A node is a ROS program. The package is this one, topic publisher. But here I can create other programs which will have other nodes. Inside my package, now I only have one program. But here I can create as many programs as I want. Yes? And each program will start his own ROS node. Each program I define is going to start his own ROS node. And all these programs are encapsulated, are organized inside this package. A package is just a container of ROS programs, let's say. Yes? It's a way of organizing ROS code. Alright, let me see. Okay, so I'm going to keep going. Okay, so I'm going to start explaining messages. So let's go for messages. What are messages? Well, more or less I have already explained it. What is a message? So basically a message is a way of, it's a way of sending data into a topic, yes? So a topic is going to move data, and this data is going to be represented in messages, yes? Then we have a command which is ROS message show, which is going to give us information about a specific message, yes? So in this example we are going to get data about our int32 message, which is the message that we have been using in our example, yes? In our content topic we are sending integers, which are this int32 message. So here I'm going to come here, I'm going to execute this command, ROS message show standard underscore messages, which is the ROS package that contains the message, and int32, yes? So I'm going to copy paste this command, and this command is going to give me information about the int message. And here I can see what this message contains. This message only contains a variable which is named data, which is of the type integer32, yes? So this is a very simple message because it only contains one field, yeah? It contains one field which is named data, yes? So now I'm going to answer that user, I don't remember the name, but with this command I know that the int32 message contains a field inside which is named data and which is of the integer type. So here in my code in the first line, I am creating the variable of the int32 message, yes? But now, if I want to give it a value, I need to access the actual variable which is inside this message, which is data, yes? As you can see here, from the information of the message, we can see that the field is data, is named data. So that's why first I create the message variable here, and then I access the field, the data field, in order to assign a value to it. Yes? So that's why. That's how we know that we need to access this data field. Yes? Because we know it using this message, the ROS message show message. Yep. All right. Okay, so now we have finished the publisher's part, and here we have an exercise. But before this, let me have a look at the chat again and see how things are going. Okay, I can see here Tuhit Ahmed. He says a node can be a publisher node or a subscriber node, and nodes communicate using topics. Yeah, that's right. So a node is just a ROS program. Then a ROS program can be a topic publisher. Then that ROS program, what it's going to do is to publish data into a topic. Then another node can be a ROS subscriber, which means that instead of publishing, it's going to subscribe to a topic and get the data, get the messages from this topic. Yes? Then these two nodes, the node which is a subscriber and the node which is a publisher, they are going to communicate through a topic. Yep? Then from the publisher, we are going to publish the messages into that topic, and from the subscriber, we are going to read these messages from the topic. Yes? So very good comment. Right there. All right, let me keep going. Raul Catacor says, okay, now I'm getting it. Thanks, Alberto. Okay, great. I'm very happy that you have understood now well. So, excellent. I can see here also another nice comment from Alex Charters. Nodes can both subscribe and publish to topics. Think of topics as pipes that nodes can connect to. They can put info in the pipe or get info out of it. Yep. So that's exactly it, Alex. Yeah. So you can think of a topic as a pipe, and nodes and ROS programs can either put information into that pipe or get information from that pipe. Yeah, if they want to use it for something. Going well, thanks. Great job. Okay, so it seems like everybody is starting to understand this. This is super important, yeah? So this is one of the main concepts in ROS, and this is one of the things that make ROS so powerful. Yes, this concept of nodes and topics and sending information through topics and getting information from topics. So this is the thing that makes ROS so strong and so powerful. Yes. So to understand this topic, to understand this idea, it's super important. So that's why I'm happy and I'm spending time so that you understand this idea and how it works. Yeah. So very well. I'm really happy that you are understanding this. Okay, so Engineering Nation asks, in the case of Python, by ROS program, do you mean each individual script within a package? Yes. Yes, engineering, that's what I mean. Nabil Miri, can the same node publish and subscribe to topics? Yes, Nabil, it can. In fact, you are going to need to do that probably tomorrow, yeah? And in fact, yeah, so you are going to do that tomorrow, and the same node is going to publish in a topic and subscribe to another topic at the same time. Yep. Alright, so I see that everybody is starting to understand this because also you are making very interesting questions, so I'm going to keep going. Yeah? So, one second. Let me get some fuel. Alright, then we have here an interesting exercise which says create a package with a launch file that launches the code simpletopicpublisher.py. Modify the code you used previously. So this first step we already have done it. Yes? We have already done this step because we already have a package with the simpletopicpublisher.py script. Then, step 2. Modify the code you used previously to publish data to the command bell topic. So instead of publishing into the counter topic, we are going to modify this program in order to publish into the CMD vel topic. We have it here in exercise 2.1. Then step 3, launch the program and check that the robot moves. Yeah, so here we have some data for this exercise. Then the first point is the command bell topic is the topic used to move the robot. Yeah, so do a ROS topic info command bell in order to get information about this topic and identify the message it uses. You have to modify the code to use that message. Then, in order to fill the twist message, you need to create an instance of the message. In Python, this is done like this, var equals twist. So basically it's the same we have here, yes? Yes? But instead of int, we are going to need to create we are going to use another type of message. Yep, which actually it's twist. This is a spoiler from the exercise. So, in order to know the structure of the twist messages, you need to use the ROS message show command with the type of message used by the topic command bell. Okay, then, okay, I think I'm going to do this exercise with you. Yes, in order to go a bit faster. So, let's go by parts. First of all, instead of publishing into the command bell topic, I want to publish into the, instead of publishing into the counter topic, I want to publish into the command bell topic. Yeah, this is explained in the exercise. Yeah, so I'm going to change this line here. Instead of counter is cmd vel. Yep, because here we want to publish into the cmd vel topic. Alright, so I have updated this here. Then, this topic, we need some information about this topic, right? So what should I do? First of all, let me do a ROS topic list and check that this topic exists. Okay, yeah, so from the ROS topic list we can see it here. Command vel topic. Yes? So now, how do I get information about this topic? Doing a ROS topic info command vel. So this is going to give me information about this topic. So first thing I can see here is that this topic doesn't use the integer type of message. It uses a type of message which is named twist. Yes? And this message is from the geometry messages package. Yes? So, the command bell topic uses a twist message. So first thing I'm going to need to do is to import this message into my program in order to use it. Yes? So, instead of int32, I want to import the twist message. Yes? But the twist message, it's not from the standard messages package as we have here, but it comes from the geometry messages package as we can see here. Yes, so I'm going to come here, get this name, copy it and paste it here. So instead of standard messages, it's geometry messages. Yeah, so from the geometry messages package dot message import twist. Yep, so now I have imported this type of message and I am able to use it in my program. So now what I need to do is to set this message as the message for the command bell topic. Yeah, because the command bell topic, as we have just seen, doesn't use integers, it uses twists. So I'm going to change this. Yes, the queue size I can leave it as it is. Then next things I have to do. So now I'm not going to use int32 message, but I'm going to use the twist message, yes? Then I am going to rename this variable because it doesn't make sense that it's count. So I'm going to name it move robot. Yeah, or I don't know, I can name it twist if you prefer. Twist. Yes, this twist is going to contain the twist message. So now, how do I know how to fill this message? Because for the int, I needed to fill the data field. But for twist, I don't know about this. So what should I do now? Well, I'm going to execute this command, the one that we have just seen, here, the ROS message show, yeah? So I'm going to do a ROS message show of the twist message, which is contained inside the geometry messages package. So ROS message show geometry messages / twist. This is going to give me the structure of this twist message. And here I have it. Alright, so I can see here with a first look that it's quite more complex than the integer, yeah, which only had one field. Yeah, so this twist message contains two different vectors of 3 positions. Yes, so this twist message, it's a complex message. Why? Because it contains other types of messages inside it. Yes, so this twist message is composed of 2 vectors of 3 positions, each one x, y, z. Yes, which are floats, as you can see. Then, what I need to know now, it's this point here, which is explained in the data for exercise 2.1. So, in our case, our turtle robot has a differential movement, yeah? So it uses a differential drive plugin in order to move. What does this mean? This means that the robot, let me show here the axis. So this means that this robot can only move forward, yes? Forward or backward. Talking about a linear movement, yes, it only can move forward or backward. It cannot move in the y-axis, in this axis. Whoop, I don't know what that is. Yes, so it is not an holonomic robot, but a differential drive robot. This means that it can only move in the x-axis, so forward and backward. It cannot move neither in the y-axis, which would be holonomic movement, or in the z-axis, which would be a drone. Yes, a drone would be able to move up and down. Yes, but this robot can't move. So he just can move in the x-axis, forward and backward. And so this is for the linear movement. Yes, but we also have the angular movement, so the turns, let's say, the rotation of the robot. Yes, then in terms of rotation, here we have it. This robot can only rotate in the z-axis, which is this one, yeah? So the robot, actually, let me show it like this, which is going to be more interesting, yeah? So we have linear movement, which is this one, yes? And we have 3 axes, x-axis, y-axis, and z-axis. The movement in the x-axis means this movement, yes? Forward and backward. The movement in the y-axis, it's this movement. And this robot cannot do this movement. And in the z-axis, it's this movement. And the robot cannot either do these movements, yeah? So a robot can only move in this axis, forward and backward. Alright, then, for the rotation, this robot can only rotate like this, yes? In the z-axis. So he can turn left and turn right. Rotate left and rotate left, or rotate right. This is the rotation in the z-axis, yes? In the x-axis would be a rotation like this, which this robot cannot do, of course, yeah? This rotation is not possible. And rotation in the y-axis, it's not possible, neither, yes? This rotation is not possible. So the only rotation that this robot can do is rotation in the z-axis. Yes? So, let me put the robot back here. So, what does this mean? This means that from all these values, from the linear velocities in x, y, z and the angular velocities in x, y, z, the only ones I have to be worried about are the linear x and the angular z. Yes? Because the other velocities are just not possible for this robot. Yes? Then, how do I fill data here? Yes? So, if I want to put some data inside this value, inside the linear x, so what I would do is to access my variable twist dot linear, because I am entering this field, and inside the linear field I'm going to enter the x field. Yes? So I would say twist, because it's the name of the variable where I have my twist message, twist dot linear dot x. Yes? And the same goes for the angular. So for the angular, let me copy this. I would say twist dot angular dot z. Yes? And now here I can apply some velocities. Yes? So for instance, I can apply here. These velocities are by the way, are in meters per second. Yes? So you are not supposed to put a very big, if you put a 2 here, that will mean 2 meters per second, which is a lot. Yeah? So I'm going to put, for instance, 0.3 in linear velocity and 0.3 in angular velocity. So by applying a linear velocity in the x-axis and an angular velocity in the z-axis, I am going to make the robot move in circles. Yes? That's the movement I'm going to achieve. Then finally, in order to finish this program, here, instead of publishing the count message, I need to publish the twist message, which I have defined here. And this count data plus 1, I don't need it anymore. Yes? So, alright, so basically, I have it, yeah? So I have modified my publisher to publish into the command vel topic. Yes? So now, if I run this program, let me do it right here. ROS launch, topic publisher, and simple topic publisher dot launch. So now, if I execute my program, I can see the Turtlebot robot starts moving, doing circles. Yes? Because, why? Because I am publishing into the command vel topic. So let me grab here another shell, meanwhile the robot is moving. So now if I do a ROS topic echo of the command vel topic, let me do it here, I can see that many messages are being published with the linear x at 0.3 and the angular z at 0.3. So these are the messages that I am publishing from my program into the command vel topic. Yes? Alright, so great. Let me have a look at the comments section, because this is the first big exercise we have done using ROS. Okay, let me check here the comments, how they are going. I can see ability, yeah, omni, yeah, holonomic, it means that it can move in all directions. Really? Let me check here. ROS run for the test. I can see Richard Boyce. Richard Boyce says it spun out of control and fell over. Set the linear x to 10. Well, that's crazy. I mean, a linear x to 10 means 10 meters per second. So probably your robot is going to to start launching and like a rocket, and it's going to go to the moon or something like that. Remember, it's meters per second, yeah? So don't don't put very high velocities there. Okay, so I can see a comment. Can you show the IDE, please? Yes, let me show the IDE here. Here you go. Okay, excellent. I am so happy, says Master. Okay, I am also very happy that you are so happy, Master. So here we are all happy. Uncover the ID, please. Yeah, I have just done that. Very good question, Sahil Arora. I was waiting for this question. Why is the simulation still moving after I have keyed the code? That's a super good question. So, I am going to answer this question right now. Here, as you can see, I have also stopped my program, yes? So I have closed my program, but the robot is still moving. Why? Well, because the topic, the command bell topic, keeps the last message that has been published there. Yes? So the last message that I published when I closed my program was this, was 0.3 linear velocity and 0.3 angular velocity. Yes? So the last message that the topic received was that one. Yes? Then that's why the robot keeps moving. So what should I do if I want to stop the robot? Well, what I can do, for instance, is to come here, come to my program, remove this, modify the velocities, set them to 0, and now I'm going to run again my program with the velocity set to 0. And what is going to happen? That the robot is going to stop. Yes? You can see it here. And why it's keeping the last message, message that it was published? Because the topic, when it was created, the command bell topic, when it was created, it was configured like this. This means that this is a latching topic. Yes? Latching topics will keep the last message that was published into the topic. Yes? So that's why. Very good question. Okay, let's keep reading here some questions. I can see Prashant Ganesha. Can a node contain both publisher and subscriber? Yes, it can. That's possible. Marc Antonio, meters per second to both velocities? No, angular velocity is radians per second, Marco. I tried a velocity of 3.3, the robot starts tumbling. Yeah, that's a velocity very, very high. Because either 3 meters per second or 3 radians per second, it's a lot. Umur Iberg asks, can you reset the turtlebot's position in this environment? Yes, you can, super easily. So, well, super easily. Not that super easily. At this point of your ROS knowledge, yeah? It's easy, but you still don't know about ROS services, but I'm going to share the command with you. So, for instance, let's imagine that you set a velocity to your robot super high, and your robot ends up there, yeah? So you can execute a command, which I'm going to share with you. I'm not going to explain it because this is more advanced ROS stuff, but I'm going to share this command with you. I'm going to execute it as well, and you're going to see that the robot goes to the initial position, yeah? I'm going to share this command with you in the comments section so that you can execute it. Let me put it here. There you go. So if you execute this command, you are going to be able to reset the simulation and the robot to its initial position. Okay. Let's see what we have here. Okay. Okay, excellent. So let's keep, I can see that we only have 20 minutes. Time goes so fast. So, okay, we just have 20 minutes and still many things to explain. So, I'm going to keep going with topic subscribers, okay? So, fortunately, you already have the concept of topic publisher. So, to understand a topic subscriber, it's super easy now. So, basically, a topic subscriber is a node, a ROS node, that instead of publish messages into a topic, is going to read messages from a topic. Yes? So, I'm going to create here another package with this new ROS program. Yeah? So, I had this this package, topic publisher, and I'm going to create another one, which I'm going to name topic subscriber. So, catkin create package topic subscriber, and as dependency I'm going to set ROS Pi. Yep. So catkin create package topic subscriber ROS Pi. I'm going to share this command with you guys in the chat. Let me grab it here and paste it to you. There we go. Yeah. So I create this new topic subscriber package, and inside here I'm going to create this program which is named simple topic subscriber.py. So new file, simple topic subscriber I had a what space here at the beginning. So simple topic subscriber, and inside this new file I'm going to place this code here. Yes. So let me save it here, simple topic subscriber. Alright, and now what I'm going to do is to first make sure that my file is executable, topic subscriber src chmod plus x topic subscriber, simple topic subscriber, and then I'm going to also create a launch file. So I'm going to first create a launch folder here, and I'm going to create a launch file named simple topic subscriber.launch. There we go. And then what I can do is to just copy the contents from the other one, from the publisher's launch file. I can copy them from here and paste them to the new launch file and then do the proper modifications. Yeah. So that's what I have just done here. I have copied the launch file from the contents, not the name. Yeah. The name is different. The name is simple topic subscriber, but the contents, I have just copied the contents from the publisher's launch file, and then I can modify here the parameters. Instead of topic publisher, the package name is topic subscriber. Instead of simple topic publisher.py, the name is simple topic subscriber.py, and the node, instead of topic publisher, it's topic subscriber. And the output is the same. Yep. Excellent. So I'm going to save. I don't know what happened here. Let me close this. All right. So let me save this. Excellent. Then I have basically created my new package for the subscriber and placed the subscriber's code there, which I have here. Yes. Then now what I'm going to do is to run this program. So ROS launch simple. The package is topic subscriber and simple topic subscriber.launch. Yes, so I am going to execute this program, and again, nothing is happening. Yeah, so in theory, I should be, if what I have told you, that a subscriber reads data from a topic, I should be getting here some kind of data. Yes. Why I'm not getting any data here? Do you know why? Can somebody tell me in the comments why I am not getting any data here? I'm going to wait a few seconds. Okay, I can see here a question from Master. Do we always need a separate package for a subscriber, the construct? No, Master, you don't need to. So you can create I could perfectly create the subscriber in the same package as the publisher, yeah? You can create them. This is just we are doing it in separate packages so that you practice also creating packages, yeah? Because this is new for most of you, so you need to practice to create new packages, etc. Okay, so I am starting to get here some answers. Topic is wrong. The name is wrong. Your topic name is topic subscriber. Launch file name is wrong. No, because the topic shut down. Chmod plus X. We did not publish it. There we go. Two hit is the first one who has it right. So why we are not getting the data? Because we have not published it into a topic. I can see also Umur, no one is publishing to a topic. Nobody is publishing because there is no data publishing right now. Very well, so all of you are getting it right. Alright, so here, as you can see from the program code, we are subscribing to this counter topic. But nobody is publishing into this counter topic right now, yes? Because we have modified our program to publish into the command belt topic. So the counter topic, nobody is publishing there. Yeah, there is no kind of data there. So, what can I do in order to publish a message into the counter topic? So what I'm going to do, we could create a publisher or modify this one to publish again in the counter topic, but we are not going to do that. In this case, we are going to use the ROS topic pub command. The ROS topic pub command allows us to publish a message into a topic from the command line, yes? And how does it work? Well, very easy. You have to put ROS topic pub, then the name of the topic you want to publish, then the message type that this topic uses, and finally the value you want to publish. So we are going to do this right now by executing this message here. Yes, ROS topic pub. I'm going to copy it and paste it here to a shell. Here. So ROS topic pub, then counter, which is the name of the topic I want to publish to, then standard messages int 32, which is the type of message I want to publish, and then I'm going to do one thing. I'm going to do a double tap. I'm going to remove here the 5, yes, and I'm going to do a double tap here. The tabulation key, I'm going to press it 2 times. And this is going to autocomplete. As you can see here, it's going to autocomplete. Let me make this, yeah. It's going to autocomplete with the data field. You can see it there, yeah? ROS topic pop, counter, let me repeat it, standard messages in 32, and then double tap here, tap, and this is going to autocomplete like this, with the field of the int message, yes? So ROS autocompletes this for us. Then here I'm going to say, okay, the data field, I want to set it to 5, for instance. And then I hit the enter button. And now, here, in my subscribers, in the shell where I executed the subscriber, I can see the 5 here being published, being displayed, being output, which is the 5 I have just published here, yes? Also, I could, for instance, add at the end of the command an array like this, yes, /r and the number, and the 2, for instance. This is going to set a rate of 2 words. So I'm going to keep publishing this message, because if I just publish this command, I'm going to publish one time one message. Yes? So I'm going to publish one message containing the 5 value. So I can set a rate of publication so that I keep publishing this message like this. And then I'm going to keep getting in my subscriber the messages. Yes? Until I stop publishing. Then I stop getting the messages. Yes? So far so good? Alright. So let me finish this very quickly. Alright, then the subscribers code, super easy. We have the Python line telling this is a Python script. We import ROSPy, we import the integer message because it's the the type of message that we are going to receive from the topic. Then here we initiate a node, a ROS node, which we name topic subscriber. Here we define the subscriber, and we need to specify, this is very similar to the publisher, so we need to specify the name of the topic we want to subscribe to, the type of message that this topic contains, so the type of message that we are going to receive, and then also at the end, instead of the queue size that we were doing here in the publisher, at the end we specify the name of a callback function. Why? Because each time a new message is published into this counter topic, this callback function is going to be triggered, yes? So each time I'm publishing a message into the counter topic, this callback function is called. And basically inside this function what I am doing only it's doing a print. So I am printing the number, yes? In this case I am printing the data field, as you can see here, which it's the number 5. Yes, because I am publishing the number 5, so I am getting here the number 5. Yeah, this is the print that we have here inside the callback. Yeah, so this is a very simple callback, but inside this callback we could do whatever we want with the data. Yes, then we set at the end the name of the callback function that we need to define. Of course, we need to define a callback function that is going to do something. Then each time a new message is published into this topic, so let's run again this program one more time. Each time I publish like this a message into the counter topic, there we have it, the callback function is triggered. So I am accessing this print, yes? And finally here we have a ROS by spin. Basically this ROS by spin what does is to stop the program here and keep it in pause so that the subscriber is there, yes, so that the program doesn't die. Yeah, if we take out this, then the program would die and we won't be able to read anything. Yeah, so we need to put this spin to keep here spinning forever so that the subscriber is alive, and each time someone publishes into this topic I can trigger my callback. Yes, so basically this is like an infinite sleep, let's say. Yeah, all right, great. So we have explained subscribers. Let me have a look at the chat. How are you doing? How are you doing here? Did you fix it? Let's see. Nabil asks, is it possible to update values we change in the program file code without relaunching the topic? Is it possible to update values we change in the program file code without relaunching the topic? I don't understand your question, Nabil. I don't understand it. Can you try to rephrase it? Because I'm not very sure what you mean with that. Nuria Pujol is asking how to specify this complex message using poop in terminal. How to specify complex message using poop in terminal. Okay, she says that it's here now. Let me do a very quick example, by the way. I don't know if you have tried it, but for instance, here I can do a ROS topic pop of the command bell topic, which is to move the robot, do you remember? Then I specify here the twist message, and then here I do a double tabulate, and here I can fill the values as well. So for instance, I'm going to set angular velocity to 0.3 and linear x to 0.3 from here to start moving in circles. So now the robot is going to start moving in circles. You are going to see. There you have it. See? Then now I can, even if I stop here, because this is a latching topic, the robot keeps moving, yes? So now I need to publish again, ROS topic pop. I need to publish now another message with the velocities set to 0 here in order to stop it. Geometry messages, twist, with the velocities to 0. There we go, and this stops the robot. Yep. Alright, so let me keep going. Doing good, thank you. All good, thanks. What about the argument of the function callback? Okay, good question, Marco. So this here, as you can see, the callback function contains an argument. This is going to be always like this. Always, yes? This contains the whole message, yes? So this basically contains the int32 message, yes? Then here you can access the values of the message from this variable here, yeah? Message contains the whole integer message in this case, yes? If it was a twist, then this message variable would contain the full twist message. So you would access here linear x, yes, you remember? Basically, this message contains, this message variable contains the message published into the topic. Okay, alright, very good. So, okay, we have 5 minutes left to finish. It's a pity because now I think you are starting to understand very well the concepts. We have here not much to finish, honestly. So we have explained topics, publishers, subscribers. So here we have a couple of exercises, and then we are going to create a custom message, yes? Because until now, we have been using messages that are already provided by ROS, like the integer 32, like the twist message. These are messages that are already provided. So tomorrow we are going to end what is remaining, and we are going to create our own custom message. Yes, we are going to complete these exercises. First of all, we are going to do an exercise related to subscribers, and then here we have an exercise which is where we are going to combine publishers with subscribers. Yes, and we are going to create a custom message, our custom message created by us. Yes, and finally we have here a small exercise as well. So I'm going to leave this for tomorrow, and after we finish this theory, which I think it's going to be in the first hour at most, then in the second hour we are going to present the robotic challenge project, and I'm going to explain some hints so that you can solve it. Yes, but basically, since we have no more time, we are going to do this. Yes, so I'm going to stop the class here, and tomorrow, in the first half of the class, we are going to finish what we have remaining here, which is not much, and then at the end we are going to do the robot challenge project. Yes, all right. So let me come here and have a quick look at the chat. Okay, I can see a message here from Thaibat. Just discovered your video. Sadly, I didn't discover it before. Okay, well, it's never too late, Thaibat. So better now than later, you know? So welcome to the family. Welcome to the Construct family. Here he's saying Alex Charters also, post in Discord after the Discord, in the Discord server so we can help you better. Yeah, so if you have doubts, you can post them in our Discord server, and your colleagues here from the live class and also we from the staff are going to try to help you. I can see Balaji here saying, okay, let me switch back and show you my pretty face one more time. Hello, I'm still here, yeah. So let me check here. Thank you so much. It was really important lesson to hit, yeah. Yeah, it was. Today it was a very important class. Great training. Thanks, Alberto. It's saying Balaji. You're welcome, Balaji. Gloria de Felix says, "Hi all, I stopped the YouTube video a lot to make sure I took notes. I am on the Discord if anyone wants to continue." Great, Gloria, yeah. You can pause the video, of course, that's a method. So if you feel like I'm going too fast, you can pause at any moment, rewind. Also, when we finish this stream, we are going to publish this video in our YouTube channel. You have all the training from day 1, day 2, day 3, and you're going to have today the video of day 4, or also if you want to watch it at your pace. Yep. Thanks, Alberto. Thanks a lot again. Helder Camara, Nabil Miri, you're welcome. Thanks again. Good delivery. Team B, you're welcome. Engineering Nation also. Sujay is asking, are you going to cover ROS service tomorrow? No, we are not going to do ROS services tomorrow. Tomorrow we are going to finish explaining this section, the subscriber section, and how to create custom messages, and then we are going to do a robotics challenge, a project where you can apply all this. Yes, ROS services we are not going to explain. Maybe I don't know, maybe next week or in a couple of weeks we repeat this learning week. If you want to, if you are happy with this and if you support us, maybe we repeat this learning week. But I don't know, maybe we can do more advanced ROS topics like ROS services, ROS actions. I don't know, we'll see. Richard Boyce says, thank you for another great day. Sad day tomorrow. I guess you mean it's a sad day because it's the last day of training? Yeah, well, all the good things end at some point, yeah? Okay, so I see many thanks comments. I'm very happy that today everything worked good. We didn't have any problem today. All of you were able to launch your project, which is great. All of you were able, I can see that we are 350 people, which is a lot. Very well. All of you have been able to work with me to launch your project. By the way, I can see 350 people, but only 39 likes. Please, guys, give us some more love. I need to feel your love with the likes. Yeah, no, I'm just joking. Okay, so thank you very much all, and keep working, keep training your skills. Keep doing the exercises if you want of the project, and I will see you tomorrow for finishing this lesson and doing the robotic challenge. Yes, and as always, remember, stay safe, be safe, stay home. Try to don't go out your home, and we are going to keep doing providing content to you so that you can have fun learning. Let's say. You can have fun from your home learning ROS. This is our work. We are trying to do it our best. So yeah, be safe, stay home, and I'm going to see you tomorrow. Bye bye.